Hi, my name is Venelin. I'm from Text, and I will present you the semantic publishing benchmark that we've been developing the past two years. We'll start with a short introduction. The semantic publishing benchmark was inspired by the dynamic semantic publishing approach, which was first adopted by the BBC. It was first applied in 2010 for the FIFA World Cup website. Following that success is the BBC official site, and then for the 2012 website for the Olympics, currently continuing to be used. The primary use case of BBC is to provide rich, deep, in content and dynamic websites. How they do this? They first do a text mining, which automatically annotates articles with entities. Those annotations are then curated by editors before storing, and after being stored, the content is provided to the end user by a Sparko endpoint. So this is the result, actually, of this process. As you can see, it's a PDF, so we cannot see the transitions of the two pages, but the first one gives information of the football team of England, some statistics, and thanks to the aggregation which is provided by the Sparko queries, we have additional information about each information related to the team of England, like, for example, this football player, some statistics, or whatever information is related to it. So in general, the publishing and media domain can be characterized by the following features. It has constantly generating new content, which means there are constantly news which are being annotated or edited. It constantly updates existing content. As I mentioned, they're edited or removed, and constantly consuming that content, the end users, which are always reading news, browsing, or searching. The place of the semantic technologies in the publication pipeline, they're used to annotate the content, as I mentioned, through text mining, which is actually adding more metadata about the entities of information, and that after being annotated, this content can be used for multi-purposing. It can be used in various ways to extract new data or provide different kinds of view on one kind of information. So the semantic publishing benchmark, it is a benchmark for RDF databases. It simulates such a media organization, which maintains a catalog of metadata about its assets. It simulates those operations performed by real users, the consumption of metadata, and the management of that metadata. And of course, it measures the performance of both types of operations. The requirements to run this benchmark are the triple store must be able to store context-aware data, which means triple stored in graphs. It should be Sparko 1.1 compliant. It should support slight inference like RDFS. We move to the workloads. So this benchmark provides two types of agents, executes two types of agents, editorial agents and aggregation agents. We start with editorial. They're simulating the work performed by journalists, let's say, or editors with the system. This is, they run simultaneously. Those agents actually are doing insert, update, and delete operations, which are providing a constant stream of updates to the system. And the aggregation agents, they're simulating the end users or semi-automated tools used to provide content on the web. They also run simultaneously. Again, they also provide constant workload of queries from currently 2 available query mixes, basic and advanced. Later, I will focus more on those query mixes. So we have a basic interactive query mix, which contains of 9 queries. We have all kinds of queries there. There are search queries, there are full text search queries, aggregation, or geospatial. Along with that mix, we add so-called advanced query mixes. They also contain interactive queries and analytical queries. Advanced query mix adds to the basic one analytical queries, which analyze the whole data sets and provide some statistics, let's say. We have faceted search queries and drill down queries. We move to the software implementation. So the data generator of the benchmark, it uses the real ontologies provided by the BBC, also real reference data sets provided by the BBC. We also have enriched it with data from DBpedia and GeoNames. Data generator can produce data in parallel, which is really useful when you want to produce real large amounts of data. It is a deterministic, which means that 2 consequent runs of the data generator will produce exactly the same data sets. There will be no differences in the data sets. It is scalable. You can configure it to produce any number of sizes of the data. And the data generated by this data generator simulates activity of a publishing organization for a period of time. The semantic publishing test driver, it is an open source. It is now available on GitHub, so anyone can have a look at it, can download it. It runs, as I mentioned previously, in parallel editorial and aggregation agents. Both of them are providing steady update and query streams during the workload. There are no pauses. The benchmark driver validates results. But it can validate query results, but it also can validate update operations, which means, for example, on each 100 update operation, the result of that update is validated. If it is really happening or there is some kind of batching. And also the test driver gathers and reports the performance metrics at the end of the run. Actually, it reports it each second, but so you can use that statistic to get all kind of performance metrics, or to get a view of what's happening in the benchmark system during the whole benchmark run period. We have some sample results that we have used to measure GraphDB. This is a triple store that OntoText is developing. As you can see, we have started with GraphDB 6.0. The hardware used is more or less standard equipment, let's say, hardware equipment for a server. So with the results are measured with the basic query mix. As you can see, the initial results, we have 32 reads per second and 12 updates. And with the next version of GraphDB, we have increased both numbers. We are heavily using this semantic publishing benchmark to measure the performance of our engine, to test it for each new version. We would also like every one of you who is everyone who is developing or is using a triple store to use it to test this benchmark, to download it, to compile it, and to produce some results. I will add some comments to the next steps we want to do. So we want to generate a rich set of public results. We are going to play with different kinds of scales, with variants, different kind of settings of parameters, so that we will have a rich database of results with the semantic publishing benchmark. We want to add richer reference knowledge, which will make things a little more interesting by adding links between entities. That way we can utilize a little further the inference and the capabilities of the inference engines that the RDF stores provide. We'll add some queries that are exploring those links. And we want to experiment with a little more of the inference part. So until now it is RDFS, but we'll do some experiments with OWL to see what's going on, if the performance or if the benchmark will give us some more light to what's happening inside the RDF engine, the database engine. Yeah, also we have ideas to implement enterprise features, test features in the benchmark, like online backup. We are going to test various failover scenarios, let's say hardware or network failover between distant data centers in a cluster configuration. Also, we are going to experiment with various stress tests, for example, reaction to a diskful event, what's happening in the cluster when one of the nodes ends up in such a kind of event or situation. And along with all of these scenarios, we're going to add the semantic publishing workload running. So we are going to play these failover or stress test scenarios during a constant run of the benchmark workload. So I think this is the presentation. Yes.
Could you go back to the slide with the 4 tuples that you described the data? You had 3 tuples and then 4 tuples. That you said it was triples plus something.
I mean the okay. This one.
No. Oh yeah. So
actually, the data set which is the data is generated in contexts. This is the whole idea. We have creative works. The so-called metadata is called creative work. This is actually the metadata about some entities. So each of these creative works are stored in a separate context. This is the way the BBC is doing it, and this is the way I think the industry is actually trying to.
if you, can you kind of quantify what is the proportion of the graph, like megabytes? So the percentage of the graph weight that is from the RDF information and the percentage is from the context information?
Oh, probably that there is a bit of misunderstanding here. I mean, although RDF databases are known like triple stores in the last, probably 10 years, I mean, most of the engines actually work with quadruples, and there is Sparkle, which includes the so-called name graphs. So essentially each statement is not just subject, predicate, object, but also for each statement you can also have a fourth element that is name graph that allows you to do a bit of grouping. I mean, it can be used for any purpose, but it's nowadays intrinsic feature of RDF and Sparkle as a query language to deal with quadruples instead of triples. And most of the engines do it anyway. So in this particular benchmark and the way in which we've seen many people using it in publishing, you have the information about the metadata about each specific creative work, each piece of content, grouped in a single name graph that contains, say,
just a label.
100 statements.
So the fourth one is just a label that is grouping.
You can think about it any way you want. It's just a fourth URI.
Yeah.
That is part of the statement.
Structure.
And it's essentially for most of the systems a trivial statement that they should support name graphs. But that's sort of.
It's a common design pattern in many RDF use cases that everything that changes together or everything that's created together constitutes a name graph. And then when something of that changes, the whole name graph gets deleted and then some reinserted with the changes. That's quite frequent among users, and this is also the behavior that the benchmark reproduces.
Second question, in your benchmark, the first time I'm looking at it deeply, but in your benchmark, the interactive and the analytical is combined in the advanced one.
This is in the social network one. This is the semantic publishing.
He has a basic and then the advanced. And the
Oh, okay.
advanced
Right.
combines both interactive
Oh,
and analytical.
you don't have to.
Yes.
No, you don't have to, but
Yes,
the
yes,
question
yes.
is, I mean, it's a philosophical question, but in relational data, the use case, the common use case says that you have a live graph or a live database where everybody does the updates and inserts and simple selects and transactional stuff. And then if you want to do analytic works, you offload it to a warehouse, data warehouse, and then you do all the analytical work there. I'm not saying that's a good scenario or that's a good use case, but that's how it is.
But here, even the interactive could be thought of as analytical in the relational space because it's not really updates. It's just, I think there's
Yeah.
distinction between quick, like I want to do
Yeah.
like a quick lookup kind of thing, and I want to do like
This is
like
exactly-
this long analytical, aggregating kind of function. And so you want a system that can handle both a lot of people throwing little queries at it and kind of some bigger queries.
I agree that's what you want. The question is why doesn't the semantic network bench?
Well,
The other one.
put it this way.
The social network, why doesn't it do the same? Because I can argue the same. I mean,
Yeah, I
you
agree.
want to do the same thing on a social network. Why would we separate
we're
there
getting
and
ahead
next
of
here?
Separate
social
teams.
network, but I can characterize social network
No, you can answer it in the other
interactive.
direction. Why do you mix here?
Interactive. The interactive is like pretty heavy read-only queries that nevertheless we finish interactively, so within a second. These are the analytical ones are really beasts that may not finish in a second. They might take minutes in current systems and people may be okay with that. So there is the heavy and super heavy.
I
That's the difference between them.
I think the issue here is actually
Super heavy is
terminology
something
here. I think it's terminology because here what you're calling analytical
Yeah.
in the SNB is still query. Because in the SNB, some of these analytical things are represented in the query one, and the analytical one's even more heavy duty, like whole graph things. So I think we gotta actually stabilize the terminology across all two, because those are both actually according to SNB query.
Well, I think analytical would be BI there. Here.
Okay, sure,
Yeah,
but it's
okay.
again, it's just different
But
terminology.
again,
Right,
BI
okay, so
comes
we
from
can
business
roughly
intelligence
say-
warehouses where you offload the whole database and then you do the analytical on the side and stuff like that. So if that's not the use case.
Well, actually, we have provided this opportunity. If you want to measure both, it's okay. But if you want to just execute the interactive query mixes, it's yeah.
Well, the thing here is that people are used to doing that, but to like create separate systems for analytical queries. But the question is whether that's very desirable. Certainly, if these analytical queries are well, these analytical queries already help me out. Are these the how long do they run on what is a typical
Well, okay,
runtime
so,
on Virtuoso?
Well, for what's called analytical in SPB, they run a couple of seconds a piece or something like that on a small data set, but they are linear to the data set size, so twice the data takes twice as long by definition because they do go through large fractions of the data set, and that's why we call them analytical. The interactive ones tend to be lookups, so they're rather logarithmic to the dataset size, and what's analytical is rather linear to the dataset size, so they are like different classes of queries. And so also on a social network, the interactive ones are not expected to increase linearly with the database size, but the analytical ones are expected to do that because analytics is about going through a large fraction of the dataset.
And apologies for the terminology because when Ori says analytical now, it's
Right.
actually called BI.
BI, right? So
Yeah.
that's the issue
Yeah.
now here. I think you guys just should rename this to BI.
Yeah,
Right, and then there's a third one, which is the analytics.
yeah, which are
Which is a
actually
separate.
not queries but algorithms.
Right.
Yeah.
Alright.
Yeah.
But that's fine. It's not. You didn't invent the mix-ups because people have been saying OLAP, which is online analytical processing, for years, and that's not algorithms.
Yeah.
Yeah.
Yeah, maybe the algorithms need to be renamed from analytics to
Graph algorithms.
graph algorithms or algorithmics or something.
That's a cool rename.
Well, I guess presently they're called graph analytics.
Right.
Yeah.
And then the TPCH style stuff is called BI, but that's on the social network.
Yeah.
Okay. Because you'd expect people to use both benchmarks, so you don't want people to be confused.
Yeah, that's, well,
Or do you feel there's two audiences here?
the semantic publishing benchmark is by law a Sparkle thing. So the SNB is a free format thing. You can address it with any system that you like.
Bring your own query.
Yeah.
But it could be used for
SPB
RDF.
is not. It's a Sparkle thing. So there are Sparkle systems like Virtuoso who target both the SNB and SPB. But if you're not a Sparkle system, you cannot target the SPB.
Why not?
Well,
I don't see, like, long term, I see actually, property graphs and Sparkle converging and stealing from each other, and you should be able to actually load this into a property graph thing and
Well,
convert all the queries.
Some of the
Other than
reasoning,
inferencing.
some of the reasoning and inferencing is part of this benchmark. There is no equivalent for
But
that.
it's not there yet, and at some point,
It is.
no, it's there, but we need to reach it
so at
furthermore.
some point, inferencing will probably make it over
Mhm.
to property graphs.
Really?
Well, why not?
Yes.
But sure. So this SPB is typically formulated in terms of URIs and triple and stuff like that. You can make an equivalent formulation, of course, in anything else, but then the metrics would not be comparable. So it would be, let's say, too different, and that is why then you would not use the same name of the metric, even though you could implement a similar or, a functionally equivalent workload in something else. But okay, that is a matter for the committee that's going to be overseeing the development of the benchmark, whether these restrictions should be lifted and to what degree non-Sparkle, non-RDF technologies will be comparable. That's a thing that's open for discussion, but at present this thing is very specifically formulated in Sparkle and RDF terms.
Yeah.
So, wait a minute, bottom line so the bottom part, the advanced benchmark will have linearly increasing time queries, which is equivalent to the analytical benchmark in the social network. But the difference between the two
to
is
the BI. Yeah. Right.
But the difference between the two is that here it's mixed with the
Right.
logarithmic sized queries, and
No,
there
they're
it's-
not actually mixed. They're very well separated, but
The
yeah.
metrics are calculated over the analytical metric that comes out of the SPB will measure only the performance of the analytical queries.
Because they're running on the same time, so they get the
Correct.
same
So
stress.
you're running one system, okay, and this one system may run up to 4 different things concurrently. The 4 things being very simple log-style queries, a bit more complicated log-style queries, and a bunch of linear queries, plus some updates. Now the test sponsor may choose, and that's a bit unusual in the TPC benchmarks. You don't have it this way, but here the test sponsor can use, okay, I'll put so much pressure on this, I'll have so many threads driving this kind of operation, so many driving this kind of thing, and of course they will interact because they're running at the same time on the same system. And then given these settings, so many threads doing this and so many threads doing that, at this and this throughput target, I'm actually achieving the following throughputs. And this is then the benchmark score, that's a disclosure. So then you might choose, okay, if you're really good at one workload and not good in another one, then you might choose to leave out the one where you don't excel and just run one, but then you will be reporting that, okay, the one of these workloads was not addressed in the benchmark run. So in this way you got some freedom in reporting, which is not the way TPC benchmarks tend to be.
So just one more way of saying it, because we probably overcomplicate it, but you have 4 query mixes, interactive basic. That is what we really see with use cases today in publishing. Interactive advanced, that is again mean to be online interactive thing, but is more complex. Then analytical is the third one, and update queries being the fourth. And you're always supposed to get the update query mixes and have update agents that do the updates. And then you have a choice between the three read query mixes: basic, interactive, basic advanced, and analytical. Which of those you want to get?